We all go to UMass Lowell and are in plastics engineering, and this is a little presentation on a little bit of plastics and fluids, like fluid flow and how they move and why they move that way. So first question we have is, what is a plastic and what is plastics engineering is? So there are two types of plastics, thermosets and thermoplastics. The main difference being one is recyclable and one is not. So right here are thermoplastics. That's what you would make a water bottle out of.
Anything
chairs.
that you really see.
Yeah, basically anything.
A lot of packaging, anything, really. And then thermosets are different in the sense that once you kind of set them and do the reaction, you can't like reprocess them or remelt them and reshape them into something else. And in that sense, they're not recyclable. So that's the main difference between the two.
And thermosets are like rubber, epoxy, stuff like that.
In plastics, there's processing of plastics and design. So processing is how we're gonna form something like a water bottle or like a part to a car. So there's different processes you can do. You can use injection molding, which is pretty much shooting the plastic into a mold, and it just takes the shape that is in the mold. And then extrusion is another big process, and that's shooting the plastic through a screw, I guess. So conveying it through the screw, and you get an extrude. And
So you're gonna put it through a die which has a certain shape, and then it's just gonna be pumped out in that shape. For design, it's most common nowadays to use computer automated design or CAD programs. Two of the real big ones are SolidWorks and AutoCAD. And through that, you can really create anything, whether it's a mold like Ben was talking about or a die, so that you can use injection molding or extrusion, or you can actually 3D print whatever you want to build.
And there's also design softwares like MoldFlow, where you can see the design of your mold and see how the plastic is going to flow through the mold and how the part will come out.
I'm sure you guys already know that a fluid is a gas or a liquid, and so and the real definition of a fluid is it's any sort of matter that flows when a stress is applied.
And us working with polymers, polymers are non-Newtonian fluids.
So intramolecular forces are like your covalent and ionic bonds, so that's what kind of holds a molecule together. And then intermolecular forces are weaker than intramolecular forces, and that's like up there, ion dipole, hydrogen bonds. This is what holds things together, and it's the forces of attraction and repulsion between different molecules.
So all the intermolecular forces and intramolecular forces create surface tension, and which is at that molecule on the surface, the force that is between the object and the liquid. So depending on how strong the forces are, it repels more or less. So an object can sink or not sink depending on how strong the forces are.
And then there's also adhesion and cohesion. And so when you're measuring liquid in a graduated cylinder, you'll see the meniscus. And the reason for that is being the intermolecular forces. So on the picture on the right, in A, you have a concave up meniscus, and that's because the fluid intermolecular forces between the fluid and the sides of the graduated cylinder, the adhesion, so the force is strong. It's being attracted more to the side rather than to itself, where in B, the fluid's being attracted to itself from its intermolecular forces more, so it's actually concave up.
How temperature can vary the properties of a certain fluid. So when we're extruding plastic through the extrusion process, if you increase the temperature, viscosity will decrease and it will be able to flow more easily and things like that. But you don't want to heat it up too much, or the plastic can degrade and the process won't be as smooth.
again, is related to intermolecular forces. So a water molecule here, you can see that everything's very closely together, whereas this pentane chain is very linear. So the density of water is 1,000 kilograms per meter cubed, and it's because it can compact more into one space, whereas oil, which floats on water, is longer, so in the same space you can fit less chains, so there's just less molecules of it to take up the same space, which allows oil to float on top of water because of its density.
And so the density of an object is going to affect its buoyancy. Obviously, if an object is more dense than the liquid that it's in, it's going to sink. If it's equal, it's going to sit somewhere in between. If it's less, it's going to sit on top.
We have, I think, 4 different fluids, and then some objects that we're gonna put in.
So yeah, in case you couldn't see, that was maple syrup.
Yeah, that's syrup.
Yeah.
Okay.
Dump it all in, it'll separate anyways. And so this is just showing how the liquid densities are different than each other, and since they're different, they're going to separate the different ratios. That might be a little tough to see because of the color, but
Yeah, the color. It's there. It's just olive oil. Alright. So, as you can see, as we talked about, different fluids will sit on top of each other. So this shows the buoyancy of
Do the coin first.
different objects. So this is a coin. It sinks to the bottom.
Kind of hard to see in the maple syrup,
Yeah,
but it
it's
is
hard
at the
to
bottom.
see, but it's at the bottom.
It's at the bottom.
It's a bottle cap. You have to submerge it, but
And so bottle caps are made out of plastic, and oil is it's similar to plastic in the sense that it's a hydrocarbon chain, and so they have very similar densities, and for that reason, the plastic bottle cap floats in the oil.
So anything organic, because it's mostly made of water, sinks to the water level. But sometimes these raisins don't like to do that. So we'll see what happens. But-
That's simple. It'll be
A little
good.
bit into the dish though.
So the organic materials, because they're made of water, sink below water because they are water, but then they also have more makeup to them, so they have more density than water, but not the soap.
and then the pong ball floats. Although it's in the cap. It's pretty large. But it does float on top.
So the pong ball, because it has air in it, air's very light, so it floats on all of the densities. What's air, 1.3,
Yeah.
1.3 kilograms
Yeah.
per meter cubes.
while water's 1,000.
Yeah, so if you guys want to pass it around, you